Hi everybody. Today we are going to study about solid, liquid, gas, and plasma, so make sure to subscribe our channel. So let's go. In the vast expanse of the universe, matter exists in a multitude of forms, each governed by its own set of characteristics and behaviors. From the solidity of rocks to the fluidity of rivers, from the invisible gases that surround us to the electrifying phenomena of stars, the states of matter shape the very fabric of existence. At the core of our understanding lie four fundamental states: solid, liquid, gas, and plasma. Each state embodies a distinct arrangement of particles and manifests unique properties that define its behavior and interactions with the world around it. Delving into the realms of solidity, fluidity, expansiveness, and ionization, we embark on a journey to unravel the mysteries of matter in its myriad forms, exploring the transitions and transformations that shape the landscapes of our universe. Join us as we venture into the intricate tapestry of solid, liquid, gas, and plasma, unlocking the secrets that lie at the heart of existence itself. Solid. Solids are one of the fundamental states of matter characterized by their definite shape and volume. They are formed when particles, atoms, ions, or molecules come together and are held in a relatively fixed arrangement by strong intermolecular forces. Here's how solids form, and a bit more about their characteristics. Formation of solids. Solids can form through various processes, including cooling from a liquid state, solidification, deposition from a gas, sublimation, or the reaction of chemical substances. When a substance transitions from a liquid to a solid state, its particles lose energy, causing them to slow down and pack closely together in a regular, ordered pattern. The specific arrangement of particles in a solid depends on factors such as temperature, pressure, and the nature of intermolecular forces between particles. Characteristics of solids. Definite shape. Unlike liquids and gases, solids have a fixed shape. They maintain their shape even when subjected to external forces. Definite volume. Solids also have a fixed volume. Their particles are tightly packed and do not compress easily. Strong intermolecular forces. The particles in a solid are held together by strong intermolecular forces, such as ionic, covalent, or metallic bonds, depending on the type of solid. Vibrational motion. Although the particles in a solid are held in fixed positions, they do vibrate around their equilibrium positions due to thermal energy. Crystalline and amorphous solids. Solids can be classified as crystalline, where particles are arranged in a regular, repeating pattern, e.g., salt crystals, or amorphous, where particles lack long-range order, e.g., glass. Liquids. Liquids represent one of the fundamental states of matter, characterized by their ability to flow and take the shape of their container. Here's how liquids form and some key characteristics. Formation of liquids. Liquids are formed when a substance transitions from a solid to a liquid state through a process called melting or fusion. This transition occurs when the temperature of the solid increases to its melting point, causing the intermolecular forces holding the solid's particles in place to weaken. As the intermolecular forces weaken, the particles gain enough energy to overcome the forces holding them in a fixed position, allowing them to move more freely. This results in a loss of the solid's definite shape while retaining its volume. The transition from solid to liquid typically involves an increase in temperature, but other factors such as pressure can also influence the melting point of a substance. Characteristics of liquids. Indefinite shape. Unlike solids, which have a definite shape, liquids take the shape of their container. They are able to flow and conform to the shape of the container due to the ability of their particles to move past one another. Definite volume. Similar to solids, liquids have a definite volume. Their particles are closely packed together, but they are not held in a rigid structure like solids, allowing them to flow. Intermolecular forces. While the particles in liquids are attracted to each other, the intermolecular forces are weaker compared to those in solids. This allows the particles to move past each other, giving liquids their ability to flow. Viscosity. Viscosity is a measure of a liquid's resistance to flow. Liquids with high viscosity flow more slowly, while liquids with low viscosity flow more easily. Viscosity is influenced by factors such as temperature and the nature of the liquid's molecules. Gases. Gases are one of the fundamental states of matter, along with solids and liquids. They are characterized by several key properties. Formation of gases. Gases are formed when substances transition from a liquid or solid state to a gaseous state through processes such as evaporation, boiling, or sublimation. During these processes, the particles in liquids or solids gain enough energy to overcome the intermolecular forces holding them together. As a result, they break free and become more spaced out, forming a gas. Heating is a common way to provide the necessary energy for particles to transition into the gaseous state. However, changes in pressure and temperature can also influence the formation of gases. Characteristics of gases. Gases have neither definite shape nor definite volume. They expand to fill the entire volume of their container and take the shape of the container. Gas particles are in constant, random motion and move freely in all directions. They collide with each other and with the walls of the container. Gases are highly compressible because of the large distances between particles. Changes in pressure can significantly affect the volume of a gas. The behavior of gases is described by gas laws, including Boyle's law, Charles's law, and the ideal gas law, which relate the pressure, volume, temperature, and amount of gas. Plasma. Plasma is often referred to as the fourth state of matter, distinct from solids, liquids, and gases. It is characterized by the presence of charged particles, ions and electrons, making it electrically conductive. Here's a breakdown of plasma. Formation of plasma. Plasma is formed when gas particles become ionized, meaning they lose or gain electrons, creating a mixture of positively charged ions and free electrons. This ionization process usually occurs at very high temperatures or under the influence of strong electromagnetic fields. Plasma can be found naturally in phenomena such as lightning, stars, including the sun, and the auroras. It can also be generated artificially in laboratory experiments and certain technological applications. Characteristics of plasma. Plasma is often described as the fourth state of matter, distinct from solids, liquids, and gases. It is electrically conductive and responds strongly to electromagnetic fields, making it useful in various technological applications such as plasma TVs, fusion research, and plasma cutting. Plasma does not have a definite shape or volume. It behaves more like a gas but displays unique properties due to the presence of charged particles. Plasma can exhibit complex behaviors, including the formation of filaments, waves, and vortices under the influence of electromagnetic forces. Hope you like our video. Make sure to subscribe our channel and like this video. Goodbye.